Hello, College Algebra student. This video is for Chapter 5.3, Part 3. In the last video, I said that's the end of it, but I noticed that the class worksheet has two types of problems, so I decided to make short videos on the two problems. They are pretty easy to do, but I just want to show you how to. So we want to find, in the last video for 5.3, part 2, we know how to sketch a graph of a polynomial function by hand by looking at the x-intercept and end behavior. But we would never be able to find out the maximum point, like when it turns, not on the x-intercept, how high it would go, or what is the minimum point of the whole polynomial. Like in quadratic, we can find the maximum and minimum because it only turns once. But for polynomial, they might turn multiple times. So we can't really find the maximum and minimum until we do calculus. So in order to find maximum or minimum of a polynomial, we would use decimal. So here is an example. F of x is x to the fourth minus x cubed plus 1. And I want to find out what is the maximum, minimum, if any, exist, and also what is the value. So we'll just use decimal to graph it. X4 minus x cubed plus 1. So I can do f of x, or I can do y, x to the 4 minus x to the power 4 minus x to the power 3 plus 1. There we see the polynomial, and as predicted, the power of this polynomial is even. The leading coefficient is 1, so it would go to infinity on both sides. So obviously there would be no maximum point because they would just go on forever. But there is a minimum here, and if you zoom in a little better, you can see that it's around here. And what happened is decimal is very good. If you click around the turning point, they will show the minimum of that turn. So in this case is, if you click, they will show it. 0.75, 0.8945. So we're going to go back and sketch the graph. What does it look like? So it would, there is a 1, there's a y-intercept of 1, and then a 0.5. So you can say 1 here, go down like this. So this is the point, the minimum. This is 1. So that's the sketch, and it go to infinity on both sides. So no maximum. So this graph has no maximum, but minimum y is at x is equal to 0.75, but we want a y value. Y is 0.895. You can only do it if you use decimal, or when you learn calculus next year, if you need to, then you know how to do. So the two other questions that I want to go over is also application of polynomial. When polynomial usually obtained when you multiply binomials or polynomials together. So these are two common problems that we usually encounter. So it's a rectangular box. A rectangle has a length of 12 units and a width of 10 units. So you can draw the picture. 12 and 10. And then squares of x by x unit are cut out from each corner. X and x. Cut this out. So it becomes like a cardboard like that. Right? And if you fold up the cardboard, imagine you fold this up and this would stick together, they become a box. The height would be x, right? Because that's what you fold up. All the height is x. And then the length and width would be what? For this side, because originally it was 12 total. So now you cut out 2x, so it's 12 minus 2x. For the width, Originally it was 10. Now it's 10 minus 2x because you cut out 2x here, right? The whole thing was 10. And this becomes the width of the box. So what's volume? Volume, if you look at the length, width, height, so this would be 12 minus 2x, 10 minus 2x, and then times x. You can multiply it out by filing. 12 times 10, it'll be 120. 12 times 2x, negative 24x. 2x times 10 minus 20x. 2x plus 4x squared. And then all multiplied by x. So you can combine like terms of 24x and 20x, so it will be 44x. So this is 44x. And then you multiply the x inside, so that would be 120x minus 44x squared plus 4x cubed. So this volume can be modeled by this polynomial function. Example 2 is a box of length. So this is actually a box already, so no need to fold up. So this box has a length of 2x plus 1, a width of box. The width is x plus 2, and then the height is x. Find the volume. So this is very straightforward. So 2x plus 1, length, width, height, all multiplied together would give you volume of a box times x. So again, you FOIL it out. 2x times 2x, 2x squared, 2x times 2 plus 4x. 1x times x is 1x. 1 times 2 is 2. And then all of them multiplied by x. So you multiply x inside, distribute it inside is 2x cubed plus, combine this is 5x squared plus 2x. So that is the volume in terms of x as a function. So you can write it as v of x. In a function format would be volume depends on x. Right. So that's all of 5.3. And we'll do 5.4 dividing polynomial in the next video.